Welcome to the fourth installment of our MoleculeCrafter video tutorial. Here we'll actually be creating molecules and adding connectors in the actual MoleculeCrafter workspace. So previously we had parsed our mmsif file to get a formatted CSV of atomic coordinate data and downloaded that CSV to our computer. Now we open the MoleculeCrafter document workspace in Onshape. This workspace contains everything you need to model your molecule. The workspace is freely available for anyone to use. The original file is view only. To edit for yourself, you would want to make a personal copy. Typically, you can go up here to this corner and you can say Copy Workspace. I can name the copy whatever I want, but I'm just going to leave it as a copy. So once you have your own copy of the workspace, you can do anything you want with it and edit it however you would like. The first thing we want to do is import our data. It's helpful to keep all the CSVs contained in a folder. So I click on this pre-made CSVs folder. Then we want to go to this plus icon in the corner and select Import. Then we'll click on our CSV file we want to import. I can actually select all of them at once and then press Open. Okay, now I can see that they are all in this CSV file. And if I exit my file, that's good. So now I'm going to the Start Modeling Part Studio over here. Note that you can add, this is just default Part Studio. You can add more if you like by going to the plus icon and selecting Create New Part Studio. However, this Begin Modeling Studio is just the default and it's fine to use. Now, if you go to the top right corner of the toolbar, you can find the Custom Feature menu. All of MoleculeCrafter's custom features are found here. The first one we want to choose is Molecule Creator. Okay, now we can choose a CSV file. Let's see, we'll just choose the first one. Or actually, yeah, let's just go in order. DA6. And now I press the check mark and it will create it. I don't see it here, but that's because if I scroll out a little bit, it's all the way up here. Now, as you can see, this creates separate parts for each sphere. We want to be able to join these parts together because just one of these bases has 32 separate atoms in it. So the next tool we want to use is the Molecule Unitizer. I click it and then I decide on which atoms to join. First, I'm going to choose the atoms that are part of the base and not the backbone. So I just select all the atoms that are part of the base. And because this was, what was it? I believe it was an adenine. That means I want to make it red. There's a delete selected atoms option if you want to delete other atoms, but I don't, so I'm just going to check yes. And this backbone is still in separate pieces, so I'm going to go to the Molecule Unitizer again. I'm going to select all of the atoms here. It's going a little slowly right now because I'm recording my screen at the same time. But I can select all of these atoms, and then because it's a backbone, I like leaving them as light gray. And I select a check mark, and there you go. I've got 2 new parts. The next thing that's helpful is naming your parts. So I want to rename this. This was the sugar backbone of an adenine, and it was adenine number 6, I believe. DA6 on chain, I believe it was chain A, but there's an easy way to check. I can go to Molecule Creator, and yes, it's 1BNA model 0, chain A, residue DA6. Okay, and then this is the part that's just DA6 on chain A. And so I've got my first one done. The next step is to go through is just to copy everything all over again for all of the other parts. So I'm going to do that now. Now that all the parts have been modeled, we can move on. But first, you can make folders to organize your actions. I like grouping my creators and unitizers together. So if I go up here and create a new folder, and I'm going to call it molecule, can't seem to spell molecule, creators, it will create this folder down at the bottom. Now, if I select all of my creator and unitizers, I will drag them into this folder, and now they're easily organized here. So, the next step to do is to add connectors. You can add connectors in any order, but I like starting with the pin connectors which occur between bases. I think I'll start with connectors between this cytosine and this guanine. So I'm going to select all of these others, and I'm going to hide those 9 parts. Let's see, I hid 1 part too many. I want this part back. Okay. It's easier to view when I'm going top down. So, pin connectors are first. Pin connectors go between bases. And the first pin connector I want to do is the pin connector, rather than its partner, the pin socket, which is up here. Okay, so the first thing I want to do is the pin connector. I like to do all of the connectors before I do their corresponding sockets. You'll see why in a minute. So, the first thing you want to do for the pin connector is to choose the origin for the connector. If you hover over these atoms, you can see there's different locations where you can add the connector. You've got to make sure that what you're hovering over is actually the center of the atom. For instance, it can also be this mate connector on this surface, and that's not what we want. We want this mate connector right here. Okay, now I need the connector alignment point. This connector is demonstrating a bond that's going from this hydrogen atom to this atom over here. So the alignment point is the center of the atom that the connector is connecting to. So I want that point. Now we want to say which object we are going to join this connector to. This connector is going to be part of the cytosine molecule. So I'm going to click any face on the cytosine molecule, and that will connect the pin. Now, this option here creates a special type of pin, a truncated pin. If I click that and hide other parts, well, I'll show that later. Anyway, now I've created a pin connector. I can show the truncated pin connector over here. This arrow can allow me to switch directions of my pin connector. Okay, so this is the original pin connector shape. If I make a truncated pin connector, it gets rid of that point. This is useful if you have any sort of complex structure where there should be 2 hydrogen bonds to 1 atom. The way this molecular modeling tool has been set up in MoleculeCrafter, you can't actually create 2 hydrogen bonds to the same atom. If that's the case, one of those pin connectors will have to be a truncated pin and is just there visually and doesn't actually connect to anything. This doesn't apply to the standard bDNA structure, but I wanted to mention it. So I won't actually add that pin connector. But I still need to add 2 more for these hydrogen atoms to connect for those 2 points. So I'll get another pin connector. This one is starting on the hydrogen atom on the guanine, and it's going to be connecting to the cytosine, but it's going to be connected to the guanine. And I've got a perfectly aligned connector. I'm going to do that again. And I have my 3 pin connectors. Now those pins are going to pin sockets. So this works in the exact same method. I'm going to have the socket that's going to hold this pin on the guanine. It's going to originate on the guanine, so I want the center right there. It's going to be aligned with this one, so I'm going to click right there. The object to cut into is going to be the guanine. And there we see the socket. Now, we can change the orientation of this socket. Technically, you can use this arrow. It's not the most accurate, so it's often best to just type in numbers. That's not quite where I want it, so I'm going to try again. 30, 25. Sure, that's the angle that I want. Now this is the default cut for the length of this slit right here. Depending on how the printing works, you might want to change that to make either a tighter or looser fit for your pin connector. You can shorten it or choose the shortest cut. I found the default works perfectly well, but it depends on what your printer happens to be and how it happens to work when you actually print your molecules. So we'll leave it at the default for this case, but just know that it can be changed. And that's one pin socket done. We're going to do the same for these other two joints. I often like grouping these as well in another folder. I'll call those CG connectors. Okay, the next type of connector that we want to add is the duckbill connectors. Those go between the bases and the backbone. So the one that goes on the bases is the duckbill connector rather than the duckbill socket. Works the same as the other, so you'll click the center of the connector origin, then you'll click the center of the point that it should be aligned to, which in this case is an atom on the backbone. Then it's going to be joined to the cytosine, and often you want to hide once you're done aligning so that you can figure out how you want your duckbill connector to be aligned. And that's about right. So I select green check mark. And now the cytosine is fully modeled. Guanine still needs to add its duckbill connector, so I'm going to go and repeat the process. And now both of my guanine and cytosine bases have been modeled to completion. Note that I don't actually need to put the socket on this particular backbone because I have chosen one backbone to be ideal. But first, I want to do the same thing I just did for my cytosine and guanine for my adenine and thymine. I'm going to go do that now. Now that we've finished modeling the bases, it's time to move on to the backbone. The one we've chosen to be the ideal backbone is this one, the sugar connected to DT7. It's kind of hard to see where one backbone begins and one backbone ends, But when you click on the part in the part list, you can see it gets highlighted in yellow, so we can see exactly where each backbone connects to the other. You can see that this end, which has 3 atoms surrounding it, is the end that's going to hold the socket. This other end, which connects to that 3 atom end on the other backbone, is what is going to hold the ball connector. We'll start with the ball connector first. If I go here and click the ball connector, I want it to start on this atom here. I want it to be aligned with this other backbone here. And you've got to be careful that what you're aligning it with is not that. Okay, so that's a mistake. I need to go and try to click the center again. And that mate connector is actually the center of that atom. I want to join it to this backbone, and now I've created it. I can now hide this backbone here and see the connector that I've added to this end of our ideal backbone. Now it's time to add the ball socket. I want it to start at this atom and then go to this one here. Now, this is the part where it gets tricky. For this particular connector, you cannot select this same atom right here. It will give you an error and color everything in red and not resolve the entities. This is because that face essentially gets deleted when this ball socket is created. I need to click the face of any other atom on this molecule, and then it will create this socket. But, as mentioned before, if I press this one, it won't generate because this face is essentially being deleted when we add this socket. So only for this connector is this a problem, but it can cause a pretty annoying error that's difficult to figure out what's going on. So, as a rule of thumb, you could just always choose a face that's never the origin of the original connector. That's one way to never make that mistake. Anyway, now that we've covered that, this is one where the rotation angle matters. We want to make sure that we've got the rotation such that none of these 3 slots that go around cut into their side atoms. This can be tricky to maneuver and usually takes a number of guesses before you can find one that works well for all 3. Okay, that works for those 2. That one there's a little close, so if I make it not 85, if I go to 95, that one seems okay. This one's better, and that's better as well. Okay, and now I can hide this piece. And there we have our ideal backbone. Now, there's our guanine that we want. And since this is the one we're going to model, I want to mark it as such. I like to add some stars afterwards. Let's see. That's the thymine we want to model, so I will rename that one as well. And there you can see all 5 of our unique pieces that we need to create our molecular models. And that brings us to the end of part 4 of our video tutorial. We have just covered using MoleculeCrafter to create molecules and add connectors. Up next, we will discuss scaling, aligning, and stacking those parts for 3D printing.